Let's say that I tell you negative 5 is less than or equal to x minus 2, or 9x is greater than 21. To solve this, we're going to have to solve each inequality to see for what numbers x holds true. So starting with the first side, we'll add 2 to both sides. So we're going to have that a negative 3 is less than or equal to x. For the next one, we're going to go ahead and divide by 9, and that's going to be x is greater than 21 divided by 9, which, when simplified, is 7/3. What I've given you is a compound inequality. So we know that negative 3 is less than or equal to x, or x is greater than 7/3. So go ahead and mark negative 3, and it's less than or equal to. So we're going to go ahead and shade in that negative 3, since it's less than or equal to. But this is saying that negative 3 is less than or equal to x. So that means x is anything not to the left in this case, because negative 3 is not less than or equal to negative 4, but we're going to be shading it to the right, because negative 3 is less than or equal to negative 2. Negative 3 is less than or equal to 0, and so on. So we're going to be shading in to the right. We also have that x is greater than 7/3. So plotting 7/3 is going to be 2 and 1/3. So it's going to fall right here. Now this is a unique case because x is everything greater than that 7/3. So x is everything to the right of those 7/3. But we already have everything to the right of 7/3 filled in. So as opposed to drawing a circle and then shading in again, we just leave what we already have. Because regardless of whether x is greater than 7/3 or x is less than 7/3, as long as it's greater than negative 3, it's going to hold true on this number line. So if we picked a number, say 1/3. 1/3 falls right here. We know that 1/3 is not greater than 7/3, but we know that 1/3 is greater than or equal to negative 3. So negative 3 is less than or equal to that 1/3. So this inequality still holds true. If we picked negative 4, negative 3 is not less than or equal to negative 4, and negative 4 is not greater than 7/3. So you can see it does not fall within the interval for our compound inequality. Let's go ahead and take a look at an example of AND. Let's say I give you negative 1 is less than 3x plus 2, which is less than or equal to 6. Remember, since this is two inequalities, this is really a compound inequality using AND. So we're going to have two different parts. I'll show you two different ways to solve this. The first one is splitting up these inequalities. Negative 1 is less than 3x plus 2, and we have that 3x plus 2 is less than or equal to 6. So let's solve the left, and then we'll solve the right. So let's subtract 2 from both sides. Negative 1 minus 2 is negative 3. 2 minus 2 is 0, so negative 3 is less than 3x. Divide by 3, we have that negative 1 is less than x. Over here, subtract 2 from both sides. 3x is less than or equal to 4. Divide by 3. We have that x is less than or equal to 4/3. But remember, these are compound inequalities joined by and. So when I show you this on the number line, we have that negative 1 is less than x, and x is less than or equal to 4/3. So we know that we're going to circle negative 1 since x is only greater than that. So it's not greater than or equal to. So negative 1 is less than x. So x is going to be everything to the right of that negative 1. So I'm going to draw up here to start and show you that it's everything to the right. However, here we said that x is everything less than or equal to 4/3. And it's less than or equal to, so we can shade that 1 1/3 in. And it's everything to the left. But because this is a compound inequality that's joined with the word and, x has to hold true for this inequality and that inequality. So it's going to be everything that overlaps, which the overlapping section is right here. So we would shade in this middle region. And let's test a point. Let's say that x was 0. Well, negative 1 is less than 0. That holds true. And 0 is also less than or equal to 4/3. Let's try a point positive 2. 2 holds true for this because negative 1 is less than 2, but it does not hold true for being less than or equal to 4/3. 2 is not less than or equal to 4/3, therefore that number would not work at all. Remember, both inequalities must be true when joined with and. That's why we only shade in the overlapping section. Whereas with an or, regardless of whether it overlaps or not, you shade in everything that represents both. And I promised that I'd show you another way to solve this. Here, we're going to leave all the inequalities combined, but we're going to do the same steps in order to solve. So we're going to start by subtracting 2. But instead of doing it from the left and the right, we're going to do it from the left, middle, and right. So we have negative 3 is less than 3x, which is less than or equal to 4. Now we're going to divide by 3. To the left, middle, and right. So we have that negative 1 is less than x, which is less than or equal to 4/3. And this is the same thing as saying negative 1 is less than x, and x is less than or equal to 4/3. So the previous answer or this answer are the same. It's just your preference on which method you want to use, whether you want to separate and solve, or if you want to keep the inequalities together and solve. But a good thing to remember is this x is in the middle, so you're going to shade that middle region.